אז אנחנו נדבר על ההתקף של קסנדרה באזור, אני קוראים עודד פאר, אני עובד ב-RSA Security, נמצא פה הרבה זמן, מסודר 11 שנה כבר. ואנחנו עושים שירותים, התחלנו מסיירת התחילה, מה שארז הזכיר קודם התחיל בשנת 2000 עם Software as a Service כבר בשנת 2000, דאטה סנטר שאנחנו מנהלים, אז זה היה רק כרטיסי אשראי במדינות טובות, היום זה גם בנקאות מקוונת, אונליין. ויש שירות שאנחנו מספקים בשביל מניעת הונאות בבנקאות, שנקרא AdaptiveAuthentication, היום הוא רץ בדאטה סנטר שאנחנו מנהלים, ולפני כמה חודשים עלינו בגרסת פרודקשן על Azure. השירות עדיין רץ, גם בדאטה סנטר שלנו וגם באזור, אנחנו עובדים על מיגרציה של הלקוחות שלנו. והשירות הקיים מבוסס על אורקל, השירות החדש באזור מבוסס על קסנדרה בתור אונליין טרנזקשן פרוססינג דאטאבייס שלנו. לא התכוננתי לזה, אבל כן, ננסה. כולם בסדר עם זה? כולם בסדר עם אנגלית?
מתקילים אותך.
מתקילים אותי. We can try. Okay, so whenever I talk to colleagues and peers and I tell them that we're running our service and Cassandra on our service on Azure, they usually are kind of stunned. Because Azure, really? So there's an elephant in the room. It's called Amazon Web Services, and we're not running on Amazon Web Services for business decisions. It's not technical decisions, these are business decisions. But we know that Amazon are the leaders of public cloud computing. We're aware of the fact. So a bit about Azure compared with Amazon Web Services. These are the only two leaders in the Gartner Magic Quadrant for cloud infrastructure as a service. IBM and Google, they're not considered leaders by Gartner, only Microsoft and Amazon. These are the two only leaders in the Gartner Magic Quadrant for public cloud storage services. Again, not IBM, not Google, not Rackspace. In terms of computing capacity, Amazon is reported to have 10 times the combined computing capacity of all the competition, which is quite a lot. On the other hand, reports state that Microsoft has 2 times the non-Amazon competition. In terms of cloud platform revenues, Amazon Web Services has $6 billion revenues yearly, and Azure has $1.5 billion revenue. That's like number 3, 4, and 5 combined in terms of revenue. So even though this is in English, it reminds me of a sport analogy. It's kind of like the Israeli basketball league, where you have Maccabi Tel Aviv and you have you have all the rest. So I leave it to you to understand who's
Depends on the coach.
So what does Azure provide us to run Cassandra? What does Azure infrastructure as a service provide us? We'll start by talking about VM types. That's the first thing you need to choose when you want to run any kind of new process. When we started to work with Azure 2 years ago, they had one series of VM that was called the A series, and we had different instance types, VM types, from A1 to now A11. We started off testing A7, which has 8 cores, 56 gigabytes of RAM, 600 gigabytes of temporary storage, a firmware disk. And you can attach 16 disks to each VM. Each disk provides 500 IOPS, so we get 8,000 IOPS per VM. And it costs $655 monthly. Compared to that, you have the A8 VM type, which is similar in the specification to the A7 VM type. Same amount of cores, same amount of RAM, same amount of attached disks. A8 runs on 40 gigabit Ethernet. So when it communicates with other A8 and A9 VMs, you get good throughput. It costs a lot more. In our reason, we're providing software as a service, and we're as Alice said in the beginning, there's strict performance SLAs. There's strict uptime SLAs we want to provide 4 nines, and we have strict response time SLAs. We need to answer we need to analyze events in less than 150 milliseconds. So response time performance is really key to us. So we're working closely with Microsoft on squeezing out the best performance that we can, and one of the latest recommendations that they wanted us to test was to use A8 VMs to see if we get better performance since they are running on Ethernet. About a couple of months after we joined Azure, they declared that we have a new type of VM series called the D series, and there's also again different sizes from D1 to D14. The D13 VM type VM size is somewhat similar to A7. The major change in the D series was the use of SSD drives as the temporary storage. So D13 has same amount of cores, same amount of RAM, provides 400 gigabytes of SSD, and you can attach 16 additional disks, and it costs a bit less. One of the features that D series has is a newer version of processors, so it provides better performance. You can see that the D14 is just twice the amount of everything that D13 provides. About a month ago, Microsoft announced of a new D series, D2, version 2 of the D series, which is the same specification as the D series with a newer version of CPUs. So it should provide 35% improvement on the D series. About a year ago, Microsoft announced the premium storage. That's a new set of VMs that provide network attached SSD drives. So DS13 is a new type of VM that has 8 cores and 56 gigabytes of RAM and some temporary storage, and you can attach SSD drives over the network that are persistent. And we discussed that in detail. And it costs like the D13 instance, only you need to pay more as you use the attached SSD drives. I will talk about the pricing of that later as well.
Where is the instance hosted?
The DS13, same as every other instance.
Where?
It's just a new. In Azure, they have several regions across the world. No, they have in Europe and America and Latin America, APJ, all over, like Amazon.
They have more than Amazon too.
They have a bit more, yeah.
Yeah. And in China, which you don't have any presence of Amazon or Google.
So it's global distributed. Not all of the VM types are available in every region yet. Some of the VM types, like the newest G series, aren't available on all the regions. G series are the largest VMs in the public cloud. G4 isn't the largest one. But G4 is kind of comparable to D14. It has 16 cores, 24 gigabytes of RAM, 3 terabytes of SSD, local SSD. You can attach 32 disks, and it costs way more. And G5, which is the largest available VM in the public cloud, has double the spec of G4. It has 32 cores and half a terabyte of RAM and 6.5 terabytes of SSD. And I don't know what it costs, it's probably double this. And when they announced the premium storage service, then the G series also has premium storage. So you have GS14, which has, instead of 32 attached disks, you can attach SSD drives to that monster of VM. And it costs like G4 or G5, plus the additional cost of the attached SSD drives. So when we're talking about, we talked a lot about storage. These are the storage options in Azure. Every VM has ephemeral storage, which is very fast, but it's lossy. When the VM is restarted, it loses everything it had on the local drive. I don't remember how it works in Amazon, if the local drive is persistent, same. So, you understand what ephemeral does. There's the status storage, which provides 16,000 IOPS limit on a single VM. That's the 32 drives, which when each disk provides 500 IOPS. There are different availability options for this storage. You can have local redundancy, which is in the same region. You can have global redundancy, where the data is replicated across regions. Local redundancy has 3 copies in the local region, and global redundancy has 3 copies in the local region, plus 3 copies in the distant region. And there's the premium storage, which is based on SSD, and there's a per disk IOPS limit. There are 3 types of disk, which we'll see later. And premium storage provides availability, only local availability. So each piece of data that you store in that will be stored in 3 places in the same region. Premium storage has 3 types of disks, P10, P20, and PV30. Each of them has a different cost associated and provides different size, different IOPS, different throughput. There's a blog post from DataStax that came out when Microsoft announced the premium storage service, and they recommend putting the data on P30 disks and the commit log on P10 disks. In our experience, we were using P10 disks, and we tried the configuration as recommended by DataStax. We didn't see any performance improvement, so we're sticking with the P10. So you have a lot of storage options in Azure, in public clouds like Amazon. You can store the data and the logs on the ephemeral SSD, which, as we said, is lossy but provides better performance. You can get on a G5 instance, you get 100,000 IOPS and 1.5 gigabytes per second throughput. With the risk that if the VM is restarted, and they get restarted, we're going to talk about that a bit later, you need to stream the data from all the other nodes. You could store the data in the log and period storage. That's what we do at RSA. When you attach several disks to the same VM, it's better to use strike volumes. It's better than JBOD. We tested that. Right. Yeah. The VM has 16 disks attached to the VM. So you need to either let Cassandra use them as one disk or use JBOD, which provides rank 0 without the application. It does add latency. According to Microsoft, it's a single-digit number of milliseconds, between 1 and 3. The total storage capacity of the disk is 64 terabytes. If you put together the P30 disks, you get to 80,000 IOPS and 1 gigabytes per second disk throughput. While you're using the premium storage, you can still use standard storage and your redundancy to store the backup snapshots.
Are you using different option for the log and for the SS table in any way?
Yeah. The question is if we're using different disks for the log and the SS table. We did try storing the data on the premium storage and the logs on the ephemeral storage. We didn't see any great performance improvement for that. And when we're using the premium storage or regular disks, then we're storing both the data and the commit logs on the same disk. We didn't separate. VNet is kind of the Azure equivalent of the AWS VPC. It provides a logically isolated network. You can define your network topology and divide the network into subnets and provide security groups, which is called Azure network security groups. And within a VNet, the bandwidth is a function of the VM type. So for G5, it's up to 20 gigabits per second. It's not limited, but limited by the VM type, not by Azure. Azure does provide the capability of connecting different VNets. In our service, we use two VNets, one for the production data, one for management, and they're connected through a VPN gateway. We can use VPN gateways to do a really deploy our cluster across different geographies, truly global cluster. So that's the way to connect to regions, Azure regions, or AWS regions. Technology.
By the way, you have a snitch for it, like
No.
specific. So how do you define it with the network
We're
topology?
going to talk about that. So this provides the cross-region support. There are two different VPN gateways. The standard gateway, which provides throughput of 100 megabits per second, and the high performance, which provides 200 megabits per second. Your mileage may vary. We tried that out, and we got about 40 or 50 megabits per second. And it's kind of limiting in having a true globally deployed cluster. And latency is according to distance. So if you have a node in California, which is US West, and you have a node in Texas, which is US Southwest, latency is 20 milliseconds. It's the speed of light. So we talked about placing replicas. If you're familiar with AWS, you have availability zones. We're not at AWS, we don't have availability zones. They might be there sometime. Right now we have in Azure upgrade domains and fault domains. Fault domain is a physical rack, so you won't want to place replicas on the same rack, because if the rack fails, then you lose the data. Upgrade domains are logical dividing the VMs across. I'm having a bit of trouble with my English. It's a logical grouping of VMs, so when Microsoft updates the host, they won't take down all your VMs at the same time. So you have 5 upgrade domains, and 2 fault domains. It's actually not a lot more, but when you deploy a VM, it gets assigned to one of the fault domains, either 0 or 1. It could be, physically it could be like 100 racks behind that, but it gets a single number, 0 or 1. And they have 5 update domains. So when they do upgrades on hosts, the effect is less, you won't lose all your VMs. We're going to talk about what we use.
Is there any way to directly run it?
If you use the VPN gateway and across VNets, you have one VNet in one region and a different VNet in a different region, and you use the VPN gateway, you get
That's the only way to do it?
yeah. So there are 2 options for automatic deployment of Cassandra on Azure. There's the Azure Marketplace, which provides a simplified deployment. There are 2 types of deployments in the marketplace. You have a single node sandbox, that's for development and proof of concept, and you have the DataStax Enterprise Cluster, which deploys a DataStax Enterprise product on your VMs. In your account, you need to bring your own license, since it's DataStax and not Apache Cassandra. It's deployed on one region. It's not geographically redundant. You get to choose the cluster size, 4, 12, 36, or 90 nodes. You can choose your VM type, which is D12 through D14 or G2 through G5, depending on the availability of VPNs in the region you chose to deploy the cluster on. It uses ephemeral storage, and it includes Op Center. So according to Microsoft Azure, you click next, 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 finish, and after 15 minutes, your cluster is up and available, and App Center is also up and available. The other option for automatic deployment of Cassandra on Azure is Managed Cassandra. There's a company called InstaCluster which provides Cassandra as a service on different cloud providers. They provide it on Azure as well as AWS and Google Compute and one more which I forget. I'm probably expanding to more. They provide managed Apache Cassandra and DataStax Enterprise. They are partners of DataStax. They support multiple Cassandra versions and DataStax Enterprise versions. They provide the customers with App Center dashboard. They use the D-Series VMs. And they do support multi-region geographic area. So we're going to talk about two real-world use cases. The first one is from the DataStax Cassandra Summit that was held 2 months ago. Azure, Microsoft people actually spoke about how Office 365 uses Azure to collect data and analyze data per user. They want to improve user experience, and they chose to use Cassandra to store data per user. And they spoke about the deployment they have on Azure. So they're using DataStax Enterprise on Ubuntu. They're not using it on Microsoft, which is somewhat surprising, but they added support for Microsoft as a production platform only in 2.2. They're deployed on a single Azure region with 2 virtual data centers. They're also using Spark. They have one data center for Cassandra, another one for analytics. They chose to use G4 nodes. They wanted to use bigger VMs because they didn't know how it's going to work out. And now that it's up and running, they're considering using B14 version 2 VMs. They stored data on ephemeral disks, and they showed that 12 nodes can ingest 20,000 to 50,000 events per second, and when they used a larger cluster of 30 nodes, they could ingest 200,000 events per second.
Just to be clear, there's the reading or writing per second?
Most of it is writing. Later on, they use
so great compared to other platforms.
I guess you can say that it depends on the data model, and they do get into details about what is their data model. Yeah, it is what it is. And AdaptiveAuthentication, that's the service that RSA provides. We're using DS13 VMs, which have 8 CPUs and 56 gigabytes of RAM. Each VM has 16 attached disks of P10 premium storage. Currently, we're on a single Azure region, and we're using a combination of upgrade domain and fault domain for replica placement. So there's no custom stitch for Azure yet.
You're defining everything yourself.
Yeah, gossiping on this niche, and when the VM is deployed, we configure it with the upgrade domain and fault domain that were assigned to the VM.
Manually or something like
No, it's a script. Some tips from working with Azure. Your mileage may vary. They share different performance characteristics that you might expect. Some of them do work like we expected. Some didn't live up to the documentation. Microsoft are very eager to have the good partners. We get to talk to the engineers that build the services, and they want to share, and they want to be part of our service, and they provide good support. VPN throughput, like we spoke about, was lower than expected. We needed to, when we did load test and monitor our cluster, we saw that IO was a big issue for us. And we noticed that commit log flushes caused IO spikes, so we changed the flush interval and smoothed things out. And we have one table that we frequently update, and we thought that a little compaction strategy would be a good fit for that table, but turns out that on Azure, since it consumes more I/O, size-it compaction strategy is a better strategy. Yeah, that's, yeah.
You said before that the decision to move to Azure was mainly a partnership or business decision.
Yeah.
From a technical perspective, would you go that way as well?
No, we'd probably go with Amazon because they are the largest and they have they have big customers using Cassandra on Amazon Web Services.
No, and again, let's put aside the reputation part or the ecosystem in terms of real, technical differences. You said, well, I wouldn't have that problem if I were on Azure, on Amazon.
I go with Amazon because they provide more consistent and stable performance, and there are different security aspects that we didn't get into. Yeah.
I would like to widen this question. I would understand why a company without colocation would go for a virtual solution. If I understand correctly, you do have your own colocations. RSA has data centers, so I've heard. And look at it, just at the numbers that it's shown, it's not that there's a big benefit of going to the cloud. Performance-wise, we have big clusters, so I know growing sideways is linear with bare metal. So what was the decision
To move to the cloud.
Exactly.
So when we're managing our own hosting facility and we need to add hardware, it's a procurement. It's a process that takes about a year and a half to buy additional hardware. You have some knowledge about the hardware that's used in the existing facility. We get in the public cloud, we get pay-as-you-go elasticity and price cuts and some security aspects are better.
Before you had to use the higher bandwidth option for replicating between nodes, what was the satisfactory?
We tried that out.
Can you repeat the question?
So the question was if we tried the higher bandwidth throughput for the VPN, right? For the AA?
Node-to-node replication.
No, not yet. The A8 VM
I'm
type.
just curious how well it's performing for you.
Yeah.
You have so many nodes, and of course they need to replicate.
Yeah, so it's on our to do this. We want to check out. Yeah.
Usually on our Cassandra, is there any difference between Microsoft hosted Cassandra and then the standard?
The Microsoft hosted, you mean the Instacluster?
The service they provide.
The service that
Cassandra
Instacluster.
is not Instacluster. Cassandra is a service on Azure.
Yeah. We didn't try that out.
I didn't know. You tried the Instacluster?
No. I'm aware of their service. We didn't try that out.
So what are you running?
We're our own deployment. We didn't use the marketplace. We didn't use Instacluster.
So you just deploy
Still,
standard.
Apache Cassandra.
No, we're not actually using DataStax, but since we're controlling the deployment.
Oh, as I understand, Azure has 3 versions of everything in terms of data storage.
Yeah.
Cassandra has
We use replication factor for each. Yeah.
okay, 3 versions of everything. How does that work together? You have 9 versions of everything?
So I have other versions of things. When we store data on the disks, it means that if one of the disks fails, then you still, the VM doesn't affect it.
No, I understand, but
Yeah.
physically you end up with 9 versions of everything.
Yeah, that's right.
Is there any better?
Yeah,
If it's Azure, can you switch it off?
no. Yeah.
What did you find as a limiting factor? Meaning you have so many options in terms of RAM, CPU, IOPS. Where did you find that your cluster gets stuck or where you had to scale?
So the storage, that's the
IAPS.
main factor.
Because we ran into an issue, we're running rated SSDs on dedicated hardware, we're putting 30, 50,000 IAPS, and we still had load spikes to like 40. So we're not sure what that was. So curious if there's maybe it could be just pushing them too hard.
That's how, but when we do try out different game series with improved core, improved CPUs, we do see a performance boost. It's not the
Maybe
only
CPU also,
solution.
right?
Yeah.
With the Java overhead maybe.
Yeah, we didn't use Java that much yet.
The heap
Not yet.
again, no? Through the 8 gigabytes default.
I think that maybe it's 10 now, but we didn't do a lot of There's a lot to be done in the infrastructure level before you get VPNs.
And you use a single Cassandra node per VM?
Use a single Cassandra node for that. Yeah.
What did you set the flush interval to from the 10?
We reduced that to 2 seconds.
You pulled it down.
Yeah. Because it had
Too much to
saw
flush.
the logs that and the storage log that had very big spikes when the complex log big flushes, and when we put that to 2 seconds, it was easy. Don't go yet. One more talk coming up.
Good.
שנייה.